This is AP Calculus, Unit 5 Pretest Solutions. Let's jump right in. Number 1, the graph has vertical tangents at -1, -1, and 1, 1. So vertical tangents here and vertical tangents here. It also has a horizontal tangent at 0, 0. We can see that there. And for values not including the endpoints, is it not differentiable? All right, what are the 4 things that will make a function not differentiable? They are, the first thing, endpoints. Second thing is going to be vertical tangents. Third thing, I don't know why I switched the circles here, go back to here. Third thing will be sharp corners. And the fourth thing, and that's kind of the big one, is discontinuities. Continuities. That's just anywhere where it's not continuous. And there's 4 things that make it not continuous. All right, so we're looking for these 4 things. So endpoints can't have that in here. Vertical tangents, oh look, it tells us that it has vertical tangents at -1 and 1. So -1 and 1 should be included. So everything that doesn't have a -1, 1 should be crossed out. And so that's -1 and 1. Sharp corners, oh look, we have a sharp corner at 2. So that's at 2. And any discontinuities, there are no discontinuities in this graph. So -1, 1, and 2. -1, 1, and 2. Correct answer is D. Moving on to number 2. If y equals 7 is a horizontal asymptote, okay, which of the following must be true? So horizontal asymptote, that needs to be linked in our head. Kind of, there we go. Horizontal, that needs to be linked with the limit as x goes to infinity. That's really the only thing that we need to memorize. It could be negative infinity also. It doesn't really matter. But it equals whatever the horizontal asymptote. So that equals horizontal asymptote. I'm just going to say horizontal asymptote like that. So which of these has a limit as it goes to infinity? That could be the case. It could be negative infinity. And we're looking for y equals 7. That's -7. So the correct answer is E, just a regular 7. If this was a positive 7, that could have been the answer also. The negative infinity doesn't really matter. It's going all the way to the right, all the way to the left. Somewhere it has a horizontal asymptote. Perfect. Number 3. This problem is going to be a hot box problem where I take whatever's inside the parentheses and make that the hot box. I need to figure out what my C is. My C is the number that is not the H, so my C is E in this case. And I need to change all of this into a giant X. So my function is going to be the natural log of X. And now I need to take the limit. So this is my f of X. F of X is equal to natural log of X. And from there I need to take the derivative. What is f prime? F prime of X. The derivative of natural log is 1 over x, and then I need to find f prime of c. That is going to be 1 over c, 1 over e in this case. All right. Oh, and it doesn't even, we don't even need to do f prime of e. I mean, it is going to be f prime of e. That is the c that we're looking for, so it's not any of those. And our function, we didn't even have to do all that work. Sorry, it could have just been stopped basically as soon as we got to that step, because c is going to be e, so what number are you subbing in, and what is the function? So there we go. Correct answer is A. On to number 4. So I'm taking the derivative of all of that at x equals 1. So take the derivative, then plug in -1 for x. Okay, derivative of each of these, we don't like fractions, so let's rewrite this as we're taking the derivative of x to the -3 minus x to the -1 plus x squared. Now that we have that, derivative means we're going to multiply down and then subtract 1. So if I multiply down, it's going to be a -3x, and then I subtract, so it's going to be -4. Multiply down, it's going to be a positive x, and then of course we're going to subtract, so -2, and then multiply down, so plus 2x, and then subtract 1, so it's just to the power of 1. And then we have to plug in 1, so at x equals 1, substitution bar again. So at x equals 1, I mean, substitution bar, you don't need it here, but I mean, this is the formal way of saying this. So plugging in x equals 1, 1 to the power of -4 is just 1, so that's going to be a -3. All of this turns into a -3 plus the 1 subbed in to x to the -2 is 1, plus 2 times 1 is 2, so all of this adds up to 0. All right, number 5. For number 5, we're asking about extrema. So what's the definition of extrema? Extrema. Extrema is where f okay, I can write it better here. F prime has a sign change. Sign change. And the easiest way to determine that, if we're given f prime, is where do I have an odd power? So I have an odd power there, but an even power there, so don't worry about it. And what is the x value that will make this 0? That is x equals -2. There's only one value that will make our function have a relative extrema. So correct answer is B. On to number 6. Let f be the function defined by this, which of the following must be the equation of the line tangent. So equation of the line tangent, this, whenever you see this, it's always going to be y minus box, y minus the y coordinate is equal to slope times x minus the x coordinate. You need 3 things. You need x or y coordinate, slope, and x coordinate. So it gives us the x coordinate. We have -1. I can fill that in right here. So -1, -1, and we don't have anything else. So we can find the y coordinate. We just plug in -1 into this equation. So let's do that now. So plugging in to find this, we have 4 times -1 cubed minus 5 times -1 plus 3. And -1 cubed is -1, so this is going to be -4. -5 times -1 is a plus 5, and then plus 3. So that's going to be 8 minus 4, which is a positive 4. So our y coordinate is a 4. And now we need to find our slope. Slope is found by taking the derivative of f. So if I come back here, so f prime of x, that's going to equal, multiplying down, so it's going to be 12x squared minus 5, and then no number out here because derivative of a constant is 0. And now I need to plug in x equals -1 to find what the slope is at -1. So f prime of -1, plugging that in, gives me 12 times -1 squared minus 5. And -1 squared is 1, times 12 is 12, minus 5 is 7. This implies it's 7. So the slope up here is 7. And now we need to simplify this so that we get one of these answers. And here we go. So it's y isolated on the left, so let's isolate y. Y equals, and it's going to be 7x. Distribute the 7 into the -1 is a positive 1. 7 times 1 is a positive 7, so plus 7. And don't forget your 4 that you moved over, so plus 4. So it's 7x. Y equals 7x plus 11. Do we have that? We do. Okay. So the correct answer is C. Moving on to number 7. If capital F and lowercase f are continuous functions such that capital F prime is equal to f for all x, then this integral is what? So I need to, this is basically saying I can go backwards and I can get capital F. If I go backwards, I can get this capital F. And that's seen by saying, okay, if I take the integral of both of these sides, I could take the integral of f prime of x. You don't have to do this, I'm just showing you why this works. And I take the integral of the right, just taking the integral of both sides, f of x. You'll notice that when we take the integral, you always get rid of a prime, so that means that I'm saying that f of x is equal to the integral of lowercase f of x. So it's just saying when I go backwards for f of x, I get capital F of x. So when I do this integral, this definite integral, what do I get? So when I do the antiderivative of f of x, I just showed you that it is capital F of x. So it's going to be f of x, but evaluated between a and b. Okay, so when I plug in a and b, what do I get? I just get capital F of b minus capital F of a. And that is right here, d. So it's just kind of this definition that's playing with, but in all the AP calculus tests, this is always going to be true. You don't have to derive this like I just did. This is always going to be true. Memorize this. When I go backwards from lowercase f, I get capital F. All right, moving on to number 8. All right, so each of these regions is an area of 2, and we're trying to figure out what this definite integral is. So this one is a little bit tricky, but you have to separate this into 2 parts. You first separate it into the integral from -3 to 3 of f of x. It's kind of like the distributive rule of the integral. And then also we want to add that to the integral between -3 and 3 of 1. I guess both of these should have a dx in them, dx to be formal. When you do that, this one is a little bit more clear. Between -3 and 3, so we add all these up. I had a -2, a -2, and a +2. So all 3 of those add up to a -2. And then this is our shortcut for doing constants, which is do b minus a multiplied by the function. So 3 minus negative 3, I could write this out here. You do b minus a, I was about to write a, 3, and then you multiply that by whatever the function is, which is times 1. And we're adding those two together. So I have a negative 2 plus, and this is going to be a 6 times 1, which is 6. So negative 2 plus 6, and that is going to become a 4. Correct answer is C. On to number 9. For number 9, we're given this weird fraction. Let's not make this a fraction. We don't like fractions in calculus. So if I do that, it's going to be x squared and then times e to the x cubed dx. We got rid of our, negative x cubed dx by bringing it up. It becomes negative. Perfect. Now that's not a fraction. We have to figure out what is going on here. So we know that we have the more complicated thing on the right, and it happens to be an E. So we're actually in E house here. So in E house, tree house, our U is this thing up here in the tree house. Our U is negative x cubed, so the derivative of negative x cubed is negative 3x squared. The point here is it's not 1. If it was 1, then we can just go straight forward and do the integral, but it's not 1, so we have to use taxman or we have to use U substitution. So let's use taxman, because that's a little bit faster. So we need a U for taxman, we need the taxman, and we need the derivative of U. So our U is our negative x cubed. Our taxman, that's a guy knocking at the front door. He's our x squared. And the derivative of U is a negative 3x squared. All right, so when I make this into a fraction, that's going to be negative 1/3. So let's go ahead and pay the taxman. So this is now going to become the integral of negative 1/3 e to the negative x cubed dx. Perfect. And, oh, sorry, I should have written e to the u dx. Perfect. So this negative 1/3 can go to the outside, and you're really left with just the integral of e to the u. So this thing is now turning into, should have done an arrow there too, this is turning into negative 1/3 on the outside. And now I'm going to take the antiderivative of e to the power of u, and that is just e to the power of u. And instead of writing e to the power of u, I'm going to say e to the power of negative x cubed. And we need to always remember our plus c. Let's see if we can find that in here somewhere. So I'm looking for negative, there it is. So they brought the e to the x to the power of 3 down to the denominator because of the negative power, and it is a negative, and the 3 there matches up with this 3. So the correct answer is C. Moving on to number 10. So for number 10, we have another E house, no fraction this time. In E house, we have our U, and when we take our du, it's not 1, so we're using taxman or using U substitution. Let's use U substitution just to mix it up a little bit here. So for U substitution, we need a U, and then we'll find the derivative of U, and then from the derivative of U, we'll find whatever this is, and that's going to be dx from that. So our U is going to be x to the power of 4. Our du is going to be 4x to the power of 3. And from that, it's du dx, sorry, with respect to whatever this number, or what this symbol is. From here, we need to solve for dx. dx is going to equal du divided by 4x cubed. And when I sub that in, this equation now becomes, so after doing all of that, the equation now is the integral from 0 to 1 of, I still have my x cubed, e to the power of, no longer x to the power of 4, but e to the power of u, and that's going to be multiplied by dx, and we know what dx is actually du all divided by 4x to the power of 3. And notice that we have x to the power of 3 and x to the power of 3, so those will cancel out, and I'm really left with 1/4, I guess the integral of between 0 and 1 of 1/4 e to the power of u du. Perfect. Now we can take the antiderivative. Antiderivative of e to the power of u is just e to the power of u. So this is going to turn into 1/4 e to the power of u. And I'm not going to write u here. I'm just going to write x to the power of 4 to skip a step. X to the power of 4. And then that's evaluated between 0 and 1. So always be careful with e. When you sub in 0, the answer is not 0. You'll probably get like a 1 or something. So just be wary of that when we do this. So when I plug in 1, 1 to the power of 4 is 1, e to the power of 1 is e, e times 1/4 is 1/4 e. So I have e over 4, 1/4 e, same thing. Now I'm going to sub in 0, and I'm going to subtract that from my first part. When I plug in 0, 0 to the power of 4 is 0, e to the power of 0 is 1. 1 times a fourth is a fourth, so this is minus 1/4. And if I factor out a fourth, then this is going to be 1/4 times the quantity of e minus 1, and we see that is the answer for A. Moving on to number 11. So this is the integral between 0 and pi over 3 of this trig function. So just kind of straightforward. What is the antiderivative of sine? Anti-same means change. So it's going to be a, I'll write this down here, it's going to be a negative cosine. And, oh, I was skipping ahead. Sorry about that. So the u here is 3x. du is 3. It's not 1. So we're using u substitution or taxman. Let's just go back to taxman because that's faster. So we need our u. Our u is 3x. We need the taxman. Taxman is 1. And we need our derivative of u, which is equal to 3. So we pay the taxman with 1/3, and our equation becomes the integral between 0 and pi over 3 of sine, sorry, not sine, it's 1/3 sine, 1/3 sine of u dx. Okay, so from here, we're going to take the antiderivative, and again, anti-same is change, so it's going to be a negative cosine, negative 1/3 cosine, I'm forgetting that 1/3, negative 1/3 cosine of u, and I'm not going to write the u, I'm going to skip that step, it's going to be 3x. And that's going to be evaluated between 0 and pi over 3. So when I plug in pi over 3, that's going to be cosine of pi. Where does cosine of pi live? So let's go ahead and make our little chart. This is 0, that's pi over 2, that's pi. So we're talking about this point right here. Cosine is the x-coordinate, so our x-coordinate here is negative 1. So cosine of pi is negative 1. Negative 1 here times negative 1/3 is a positive 1/3. So positive 1/3. And now plugging in 0, cosine of 0, we're talking about this point right here. What is the x-coordinate? Because I'm talking about cosine. The x-coordinate is 1. So 1 times negative 1/3 is negative 1/3. So it's minus negative 1/3. And that's going to be negatives kissing, so it's going to be 1/3 plus 1/3, and that is going to be 2/3. And the correct answer here is D. Moving on to number 12. So the function is defined by this piecewise thing, or I'm trying to find the integral between 1 and 5. And notice that 1 and 5 includes this suspect point of 3, so we're going to have to separate this into two different integrals that's separated at 3. So when we do that, we're going to have the integral between 1 and the suspect point 3, and we're going to add that to the integral between the suspect point 3 and 5, because if I add these up, it goes from 1 to 3, 3 to 5, that is 1 to 5. All right, so between 1 and 3, which function am I using? And this less than 3 is talking about here because between 1 and 3, so it's 2, and then dx. And then this function, or this function that I'm using here is x minus 1, because the last one, x minus 1, all of that dx. And now I need to do my evaluation. So this is the antiderivative, or the integral of a constant. So that's going to be 3 minus 1, which is 2, times 2, which is 4. Again, it's b minus a times the function. So that guy gives us 4. That's a quick shortcut. And if you want to write that down too, it's b minus a times whatever the function is. And if you don't like writing f of x, you can even say that this f of x is really just going to be a number because it's a constant, right? You can maybe even say c if you don't like the pound symbol, or the octothorpe as it's formally known. Going to this one, so we need to take the antiderivative, so let's go ahead and do that. So this is going to be x squared, divide down, so 1/2, minus x, and that's evaluated between 3 and 5. So what is that going to be? When we plug in 5, we're going to get 5 squared, which is 25, and then half of that, so that's going to be 25 over 2 minus 5. So I'm going to actually write that all out because I'm going to forget. So that was 25 over 2 minus 5, and I'm going to subtract when I sub in 3. 3 squared is 9, half of that is 9 over 2, 9 over 2, and minus 3. So don't forget your parentheses here. And now to simplify this all down, so 25 over 2 minus 5, and I'm going to make this 10 over 2, so we'll say that's going to be 10 over 2, and this thing is going to be 6 over 2. So 25 minus 10 is 15 over 2, and that's going to be subtracting 3 over 2, and that is going to become 12 over 2, which is 6. Remember, so this whole thing here is 6, and this whole thing was 4, so I need to do 4 plus 6, and we get the correct answer of 10. Moving on to number 13. So the graph is shown above. What is the value between -1 and 4? All right, so go ahead and shade in the areas that we're looking for. Looking for that area and this area right there. So this one is negative, that one is positive. Let's separate it into easier shapes. I'm going to use red here. So we have a triangle that I'm going to make into a rectangle, so don't make a mistake. That's a triangle, which I'm again making into a rectangle. That's a triangle, which I'm going to make into a rectangle and a rectangle. So we have a rectangle, 2 rectangles, and 3 triangles. This triangle, it's between -1 and 0, so that's a distance of 1 by 2. So this whole rectangle has an area of 2, which means that triangle has, an area of 1. Maybe I should just make that really dark. So I have a 1, and then this rectangle is a 1 by 2, so it has an area of 2, so plus 2. And then this triangle is the same as that triangle, so it has an area of 1, so plus 1. And now these are all going to be negative. So this was a 1 by 1, so this square has an area of 1, which means this has an area of a half, 0.5. So minus, I should put a negative there, minus 0.5. And then this rectangle is a 1 by, I think that's a 3 or 4, so 1 by 1, so that has an area of 1, or a -1 because below, so minus 1. So these 1's cancel out, and I'm left with 3 minus 0.5, so 2.5 is the correct answer. Correct answer is B. Moving on to 14. So I'm looking at the integral of this function. What house are we in? We are in power house, because it's the power of 5. So power house means our u is inside the parentheses, and let's use taxman because it's a little bit quicker. So taxman, we need a u, we need a taxman, and we need a du. Okay, the u is obviously the stuff inside, so that's 3x plus 1, 3x plus 1. The taxman, there is no taxman, so it's just going to be 1. The derivative of u, derivative of this is 3. This fraction here, 1 over 3, is just a third. So we're going to pay the taxman with a third, so this integral now becomes the integral of 1/3 of u to the power of 5, and then I guess dx, if we're kind of being formal about it. Now, how do we do the antiderivative of this? So the 1/3 is going to remain, so I'm still left with a third here, and then this is going to go up a power, u to the power of 6, u to the power of 6, and then divide down, so 1/6. So it's going to be 1/3 times 1/6 u to the power of 6, and that's always going to be plus c at the end. Now let's resubstitute what our u was and multiply these fractions. So fractions multiplied is going to be 1/18, and already I'm seeing an answer here. 1/18, and then u is 3x plus 1, all that to the power of 6 plus c, and yep, correct answer is indeed A. On to the 15. So we have this guy, and we don't like radicals, so let's go ahead and immediately rewrite this. This is going to be x times 4 minus x squared to the power of 1/2. All right, what house are we in here? Which house is more important? This one, this is power house, even though it was a square root, it is still power house to the power of 1/2. So power house means our u is inside, that's 4 minus x squared. If I take the derivative of u, that is definitely not 1, so we're going to be using u substitution or taxman. I feel like we've been using taxman quite a bit. Let's use u substitution here. You can use either one. So our u is 4 minus x squared. We need to find our derivative of u with respect to x, or with respect to whatever this was, and that is going to be negative 2x. And I need to now solve for dx. dx is equal to du divided by negative 2x. So now let's go ahead and use all of that to sub into our equation right here. So we have the integral of, I still have that x, and this is going to be a u, and sorry, I forgot my dx there too. I'm just trying to make that correct. U to the 1/2, and now dx isn't there. dx is now du over negative 2x, so this is going to be du over negative 2x. And notice here that we have x's on the top and bottom. Otherwise, we would be in multivariable calculus, which we are not. And what do we have here? So this is really a negative 1/2. So let's go ahead and take the antiderivative here. So when I take the antiderivative, u to the power of 1/2, I'm going to go up a power. 1/2 plus 1 is 3/2, so this is u to the power of 3/2. I still have that negative 1/2. I'll put that here, negative 1/2. And I'm going to divide down with the 3/2 too. So that's going to be times 2/3. Times 2/3. So this is going to become negative 2/6. And actually, that's not necessary because these 2's will cancel out. That's negative 1/3 still. So I'm going to say negative 1/3. Oh my god. I'm making my mistake here too. Plus c. All that was plus c. Plus c. So this is now negative 1/3. And instead of writing u to the power of 3/2, I'm going to actually substitute what u was. That's 4 minus x squared. 4 minus x squared. And that's the power of 3/2. Don't forget my plus c. All right, which one of these looks correct? So it needs to be negative. So all the ones that are positive, get rid of those. All right, there needs to be a 3 in the denominator, so it can't be this one. And which of these looks like it's correct? Well, that one has a weird x squared out in front, so I don't think it's that one. And the correct answer here is, yep, it's E. All right, number 16. Number 16, we have a fraction. Let's get rid of that fraction. This is going to be integral from 1 to 2 of x to the power of negative 2 dx. And from there, it's just the antiderivative of this, so it's going to be x to the power of negative 1, divide down, so negative 1, x to the power of negative 1. That's evaluated between 1 and 2, so let's go ahead and sub those in. When I sub in 2, that's going to be, maybe I don't like this form, because negatives will probably confuse a lot of us. I'm going to go ahead and rewrite this as negative 1 divided by x, evaluated between 1 and 2, and now it's a lot easier to sub these in. So when I plug in a 2, I get a negative 1/2. So a negative 1/2, and I'm going to subtract. What happens when I plug in a 1? When I plug in a 1, it's a negative 1, so a negative 1. Double negatives, so negatives kissing makes it a plus 1. So it's 1 minus a half, and that's just a half. So the correct answer here is C. All right, number 17. So we have dy dx is equal to this. Then y is what? Okay, so dy dx, that's another way of saying y prime is equal to cosine of 2x. So when I'm asking for y, I'm asking to go backwards, to get rid of that prime. So it's really saying take the antiderivative. If I did that, I would get the, I'll do this in a different color to be clear on the notes. I'm taking the antiderivative of this, so I'll get a normal y is equal to something over there. So this question really boils down to, what is the antiderivative of cosine of 2x? So cosine of 2x, the u is going to be 2x. du, the derivative of the inner, is 2, and it's not 1, so I'm using u substitution or taxman. I'm going to choose taxman just arbitrarily, randomly. So I'm going to say that my u was equal to 2x. My du, sorry, that's not what comes next. My taxman, there's nothing, so I'm going to say that's 1. And my du, the derivative of this is, well, my equal sign is weird. My derivative is 2, so my fraction here is a half. So I'm going to pay the taxman, and that's going to be 1/2 cosine of 2x, and I should really have a dx there, I guess, if I'm being formal about taking the antiderivative. So when I take the antiderivative, anti-change means same, so don't add any negatives. So it's going to be 1/2 of sine of 2x, and don't forget your plus c. Do we see this up here? 1/2 sine of 2x plus c. It looks like it's c. Just checking all the rest. Yep. So the correct answer is C. Number 18. Almost there. So this guy, you might think that this is a u, the inner, but notice that you don't really have a house if this is your u. So you're not really in any house, which means you're actually distributing this integral into each of these terms. So this is really the asking for the integral between 0 and 2 of 2x cubed plus the integral between 0 and 2 of 3. And I guess both of these should have a dx. So, and there was some confusion on the self-check. I think it was 5.4, a similar problem to this on number 1. And it's just, if you're not in a house, just apply the distributive property with the integral. So what is this guy? If I take the antiderivative, this can go up to the power of 4, x to the power of 4, divide down, so it's 2 over 4. The 2 is still there from last time. And that's evaluated between 0 and 2, plus this guy. This guy is just a constant, so again, the rule is b minus a times the number, so 2 minus 0 is 2. 2 times 3 is 6. And this now gets evaluated, so plug it in 2 to the power of 4, that's going to be 16, and that's going to be, this is a half. Half of 16 is 8. 8 minus, And when I plug in 0, 0 to the power 4 is 0, times a half is still 0, 8 minus 0. So 8 minus 0 plus 6, and that is 14. Correct answer is C. Really close to the end. Here we go, number 19, 2 more problems left. I'm taking the antiderivative of this. Now I am in a house because I have to the power of 2. So now I have to ask myself, what's on the inside of this powerhouse? Inside is x squared plus 1, so u is that, and du is not 1. So we're using Taxman or u substitution. I'm feeling like a u substitution. So u is going to be x squared plus 1, and I need my du dx, and that's going to be a 2x. That means, what is my dx equal to? That's going to be equal to du divided by 2x. Subbing all of that into my new, or my old equation, that's going to be integral of u squared, and then dx is now du over 2x, du over 2x. And we have a problem, because look here, we are in multivariable calculus. Look, there's an x there and a u there. That's a problem. So how do we remedy the problem? And the answer is always, and I think it's always, distribute. Like, go ahead and multiply this out. We need to multiply x squared plus 1 squared out. So when we do that, it's going to be, I'm going to FOIL x squared plus 1 times x squared plus 1. And when I FOIL, I'm going to get an x to the power of 4 plus 2x squared plus 1 when I do all the FOILing and simplifying. And now, if I take the antiderivative of this thing, dx, it's much easier because I'm not in any house. This is to the power of 1, and I'm going to do the integral of each of these individually. So doing that individually, so x to the power of 4 is going to go up a power and then divide down. This is going to go up a power, x to the power of 3, divide down, so 2/3. 2 is still there from last time, and plus x. All that plus c. Do we see anything like that? X to the power of 5, 2/3 x, blah, blah, blah. Yep, correct answer is E. And sometimes you'll have to FOIL like this, but generally speaking, it's always going to be multiply them out using FOIL or some other method, whatever you like, for these types of problems. And on to our final problem, number 20. We have a fraction. I don't like fractions. Let's go ahead and get rid of that. So this is going to be 2 to 3 of x times x squared plus 1 to the power of -1. All right, so what house are we in? We're in power house because of this thing. So let's go ahead and say that, let's just deal with Taxman, just to go fast through this last one. Taxman, we need our u before we do that. U, Taxman, and our du. So our u is going to be inside here. That's going to be x squared plus 1. X squared plus 1. Our Taxman is out front knocking. He says he's x. The derivative of u is 2x. So when I simplify this, we don't have a variable rate. Perfect. This is going to equal 1/2. 1/2. So pay the Taxman. This thing is now going to be integral between 2 and 3 of a half. He's been paid, times u to the power of -1. All right, now we need to take the antiderivative. When I take the antiderivative of u, add 1, and I get 0, divide down. Oh no, I've divided by 0. Whenever you divide by 0, you know that you're using that special rule where you're actually taking the natural logarithm. So this thing turns into the natural, still my 1/2 times the natural logarithm of u evaluated between 2 and 3. I'm running out of room, so I'm going to do this down here. I'm going to just rewrite that really quick. Natural log of, and it's not going to be u. It's going to be, u was x squared plus 1, x squared plus 1. And that's going to be evaluated between 2 and 3. So looks like these aren't really simplified that much. Hopefully, let's see what happens. So when we plug in 3, 3 squared is 9, plus 1 is 10. So this can be natural log of 10. So it's going to be 1/2. Maybe I should say this here. This is going to turn into 1/2 of the natural log of 10 minus, and here we go, plugging in 2. 2 squared is going to be 4, plus 1 is 5, natural log of 5, and 1/2. So 1/2 natural log of 5. Do we see that anywhere? 1/2? Yep, there it is. It's E. Final answer. All right, thanks for watching. Text me if you have any questions. Bye.